Welcome to the future, a world where connectivity is about to take another giant leap forward. 5G has already transformed how we communicate, stream, and interact with technology. With ultra-fast speeds, low latency, and the ability to connect millions of devices seamlessly, 5G has changed everything, from smart cities to autonomous vehicles and telemedicine. But as impressive as 5G is, it's just the beginning. Today we're going beyond what 5G can do and stepping into the next big evolution. 6G. Imagine a network that's 100 times faster than 5G, offering speeds and responsiveness that blur the line between physical and digital reality. With 6G, the possibilities are endless. Holographic calls that feel like you're sitting across the table, immersive augmented reality that doesn't lag, and real-time responses that make smart cities even smarter. We're talking about a world where communication is instant, intelligent, and deeply integrated into every aspect of our lives. But why do we need 6G? As our world becomes increasingly digital, the demands for higher speed, greater capacity, and enhanced interconnectivity keep growing. The devices we use are becoming smarter, and the volume of data they generate is skyrocketing. To keep up, we need a new generation of technology, a generation that can connect not just people, but everything around us, from the smallest sensors to entire virtual worlds. In this video, we're going to explore what makes 6G the next monumental leap in technology. We'll dive deep into how it works, the groundbreaking applications it will enable, and how it will completely redefine what's possible. Buckle up, because the future is coming faster than you think, and 6G is leading the way. To understand why 6G is such an exciting step forward, it helps to take a journey through the evolution of wireless technology. It all started with 1G back in the 1980s, the very first generation of mobile networks. It was simple, purely focused on voice calls, and not exactly reliable by today's standards. But it was revolutionary. It made the idea of mobile communication possible. Then came 2G in the 1990s, which introduced us to text messaging, a game changer in the way people communicated. Suddenly, we could send short messages without needing to talk, and this small advancement began to shift our culture toward digital communication. Next, 3G took things a big step further in the early 2000s. It gave us mobile internet, allowing people to browse the web and send emails on their phones. It was the start of a new era. Our phones became more than just communication devices. They became our connection to information, to entertainment, to the world. 4G, which emerged in the 2010s, transformed everything. It was fast, reliable, and it brought us the world of mobile apps, video streaming, and social media that we're so used to today. Streaming movies, real-time video calls, playing games online, 4G made all of this seamless and accessible on the go. Then came 5G, the current standard. Launched in the late 2010s, 5G brought blazing fast speeds and ultra-low latency. It's the technology behind smart cities, self-driving cars, and real-time remote surgeries. With 5G, we've begun to see devices talking to each other without human intervention, creating a more connected and automated world. But each generation, while powerful, also reveals the need for something even better. The way we live, work, and play continues to evolve, and the infrastructure that supports it must evolve too. Now, the stage is set for 6G, a new era that will take us far beyond just faster internet. 6G isn't just about improving what we have. It's about creating a world where our digital experiences are so integrated and seamless that they become almost indistinguishable from reality. In this next chapter, we'll dive into exactly what 6G is and why it's going to be the key to unlocking the future we've all been waiting for. Now that we've traveled through the evolution of wireless technology, it's time to explore the next giant leap, 6G. But what exactly is 6G? and why is it being heralded as the future of connectivity? Simply put, 6G is the sixth generation of wireless technology set to revolutionize how we communicate, interact, and even perceive the world around us. Imagine download speeds that are not just faster, but almost 100 times faster than what we experience with 5G. We're talking about speeds that will allow you to download a full-length, ultra-high-definition movie in mere seconds. But beyond speed, the true power of 6G lies in its ability to connect every device, every sensor, and every human experience seamlessly and in real time. One of the key aspects of 6G is ultra-low latency, essentially the time it takes for data to travel from point A to point B. With 6G, this latency will be reduced to virtually zero, which means that the lag we currently experience, even with 5G, will become a thing of the past. Imagine remote surgeries happening across continents without any delay, or virtual reality experiences that are so responsive, it feels like you're physically present. Another defining feature of 6G is artificial intelligence, AI integration. Unlike previous generations, which primarily focused on improving network speed and capacity, 6G will have AI embedded directly into the network infrastructure. This means the network will be able to learn, adapt, and optimize itself in real time. It will predict network traffic, allocate resources efficiently, and make decisions to provide the best possible user experience. This is where we begin to see a real convergence between communication technology and intelligent systems, bringing us closer to a world where machines not only connect, but also think. 6G will operate on extremely high frequencies, possibly in the terahertz range, which allows for the vast amount of data transfer required for its ambitious features. However, operating at these high frequencies also presents unique challenges, such as shorter transmission ranges and the need for advanced infrastructure, which we'll explore later. But the vision of 6G doesn't stop at individual devices. It aims to create a truly global network, extending connectivity to every corner of the planet. From densely populated cities to remote rural areas, 6G will aim to close the connectivity gap, ensuring that ultra-fast, reliable internet is accessible anywhere and everywhere. This will have profound implications for education, healthcare, and economic opportunities, especially in regions that have been left behind by previous network generations. In essence, 6G will redefine what connectivity means. It will be the foundation of smart cities, fully autonomous vehicles, immersive augmented reality, AR, and virtual reality, VR experiences, and digital twins, virtual replicas of physical entities that respond in real time. With its speed, intelligence, and reach, 6G will bridge the gap between our physical and digital worlds, making technology an even more seamless part of our everyday lives. In the next chapter, we'll explore the incredible technologies that make this vision possible. Technologies that are pushing the boundaries of physics and engineering to bring us the next great wave of innovation. To understand what makes 6G a reality, we need to dive into the cutting-edge technologies that are driving it. These technologies are pushing the boundaries of what we thought was possible in wireless communication, combining to create a network that is not only faster, but also smarter and more integrated into our lives than ever before. First, let's talk about terahertz frequencies. Unlike previous generations, which have primarily operated on lower frequency bands, 6G will harness the power of terahertz waves, frequencies even higher than those used by 5G. These terahertz frequencies allow for massive amounts of data to be transferred at lightning speed, enabling things like holographic video calls and real-time digital twins. However, using these high frequencies comes with challenges. Terahertz waves have a very short range and struggle to pass through obstacles like buildings or even heavy rain. To make this work, a network of miniature cells, or small base stations, will be used to maintain coverage and ensure stable connections even in complex environments. Next is artificial intelligence, AI. which is at the core of making 6G truly revolutionary. Unlike previous generations, 6G networks will be intelligent and adaptive, using AI to constantly optimize performance. Picture a network that can predict user behavior, anticipate demand surges, and allocate bandwidth exactly where it's needed, all without human intervention. This means more efficient use of energy and resources, better quality of service, and the ability for the network to heal itself when problems arise. It's almost like having a living, breathing network that gets smarter as it learns. Another key technology that will be pivotal in 6G is quantum communication. While still in its early stages, quantum communication holds the promise of making data transfer ultra-secure. Quantum mechanics enables encryption methods that, theoretically, are impossible to break. This level of security will be essential for the future of financial transactions, government communications, and healthcare data in a hyper-connected world. Quantum technologies could also significantly improve processing speeds and open up new possibilities for how data is transmitted and shared across the globe. Edge computing is also critical for the 6G revolution. Unlike traditional cloud computing, which processes data at centralized servers often far away from the user, edge computing brings data processing closer to where it's generated. This minimizes latency, which is crucial for applications like autonomous vehicles and remote robotic surgeries, where even a fraction of a second of delay could be catastrophic. With edge computing, 6G will be able to provide the ultra-low latency required for real-time applications, transforming how we interact with our digital environment. Then there's massive MIMO, multiple input, multiple output, technology. While MIMO is already a part of 5G, it will be taken to a whole new level in 6G. By utilizing large arrays of antennas, massive MIMO will enable far more data to be transmitted simultaneously, increasing both the capacity and efficiency of the network. This is essential for a world where billions of devices, from smart glasses to sensors embedded in infrastructure, will be connected all at once. Finally, blockchain technology will play a part in securing the distributed architecture of 6G. With so many devices interacting and exchanging data, keeping these interactions secure and verifiable is crucial. Blockchain can provide a decentralized method of securing these connections, ensuring data integrity and reducing the risk of cyber attacks. Together, these technologies form the backbone of what makes 6G not just an upgrade, but a complete reimagining of connectivity. The combination of terahertz frequencies, AI integration, quantum communication, edge computing, massive MIMO, and blockchain is what allows 6G to promise not only blistering speeds, but also a level of reliability, security, and intelligence that has never been possible before. In the next chapter, we'll dive into what all this technological power will mean for us, how these advancements will be applied in real-world scenarios to transform industries, connect communities, and elevate everyday experiences in ways we can barely imagine. Imagine a world where distance no longer matters, where you can feel as though you're standing right next to someone, even if they're halfway across the globe. This is just one of the groundbreaking possibilities that 6G promises to bring to our everyday lives. Let's take a moment to explore the real-world applications that this technology will enable, transforming everything from how we communicate to how we receive medical care and interact with our surroundings. First, let's talk about holographic communication. Today, video calls are as close as we get to a face-to-face connection, but they still feel two-dimensional. With 6G, imagine having holographic meetings with friends, family, or even colleagues. You'll be able to sit around a table with people who are physically miles away, seeing their gestures and expressions in real time, as if they were in the room with you. It's a new level of connection, one that will redefine how we interact socially and professionally, making virtual presence feel just like the real thing. Then there's the world of virtual reality, VR, and augmented reality, AR. With 6G's ultra-fast speeds and nearly zero latency, the concept of immersive digital experiences takes on a whole new meaning. Today's VR still has its limits. There's lag, and the technology can feel disconnected from reality. With 6G, AR and VR will be so responsive and seamless that they'll become a natural part of our daily routines. Imagine putting on a lightweight pair of smart glasses and instantly stepping into an interactive learning environment where you're exploring historical events, practicing complex tasks, or playing games that fully immerse your senses, all without any noticeable delay. These technologies could revolutionize education, gaming, and even training in fields like medicine and engineering, making learning both fun and incredibly effective. Speaking of medicine, remote surgeries are another groundbreaking application. With 6G's low latency and real-time data transfer, surgeons will be able to perform complex procedures remotely, guiding robotic instruments with the same precision as if they were physically present. This means that even patients in remote or underserved areas will have access to the best healthcare professionals from around the world without the need to travel. Imagine a world where critical care is no longer limited by geography, where medical expertise can reach anyone, anywhere, whenever it's needed. Now let's take a look at smart cities, urban areas that respond to your needs in real time. With 6G, cities will evolve to become fully intelligent ecosystems. Imagine traffic lights that adjust based on real-time traffic patterns, reducing congestion and pollution, or public safety systems that can detect and respond to incidents instantly. 6G will make it possible for millions of sensors embedded in everything from roads to streetlights to communicate instantly, creating cities that are not only efficient, but also much safer and more convenient to live in. Another key application will be digital twins, virtual replicas of real-world environments. Using 6G, we could create exact digital models of cities, infrastructure, or even individual buildings, allowing planners and engineers to test out changes and optimizations before implementing them in real life. Imagine being able to simulate traffic flow changes or construction projects digitally to ensure everything runs smoothly before ever breaking ground. These digital twins will help businesses and governments make better decisions, saving time, resources, and ultimately improving our quality of life. 6G will also bring transformative changes to autonomous vehicles. With the ability to communicate instantly, self-driving cars, drones, and other autonomous systems will be able to coordinate their actions with unprecedented accuracy. This means safer roads, efficient delivery systems, and even air taxis that can operate autonomously without the risks currently posed by lag in communication. The result? A transportation network that is faster, safer, and more responsive than ever before. Imagine the impact on entertainment as well. Live concerts, sports events, and even theatrical performances could be experienced in your living room as though you were really there. 6G will allow for fully immersive 360-degree video streams, coupled with haptic feedback technology that makes you feel vibrations and movements, transforming passive watching into an active experience. These are just some of the ways 6G will reshape our world. It's about creating a future where connectivity is so advanced, so intuitive, that it no longer feels like technology. It simply feels like life. The lines between the digital and physical will blur, making our experiences richer, more connected, and more interactive than ever before. In the next chapter, we'll dive into the challenges and barriers that need to be overcome to make this vision a reality. Because while the promise is grand, there are still hurdles to face on our way to the 6G future. As exciting as 6G sounds, there are significant challenges that must be overcome before this technology can become a reality. Developing and deploying 6G is not just about upgrading what we have. It's about solving complex problems that push the boundaries of what's physically and technologically possible. One of the biggest challenges is operating at terahertz frequencies. Unlike the radio waves used by 5G, terahertz waves used in 6G have extremely short wavelengths. This means they can carry vast amounts of data, but they also come with serious drawbacks. They're easily absorbed by the atmosphere and have limited range. A tree, a wall, or even heavy rain could potentially disrupt a terahertz signal, making reliable, widespread coverage very difficult to achieve. To overcome this, we will need a dense network of small cell towers and innovative ways to manage signal interference, which isn't just a technical challenge, but also a massive infrastructure project. That brings us to the next hurdle: infrastructure costs. Building the high-density networks needed for 6G involves installing thousands of new antennas, often in urban environments where space and resources are already limited. It's not just about placing new cell towers, it also means upgrading existing infrastructure and integrating edge computing nodes closer to where data is used. This is going to require substantial investment, cooperation from governments, and massive logistical efforts to bring high-speed connectivity to both urban centers and rural areas. The cost is a major barrier, especially when considering equitable global access, ensuring that 6G doesn't just benefit the wealthy or urban areas, while leaving less developed regions behind. Another significant issue is power consumption. With terahertz frequencies and high-speed data processing, 6G networks are expected to consume a lot of energy, which raises concerns about sustainability. Finding ways to optimize energy use and power these networks efficiently will be crucial. This includes exploring green energy sources and developing new power-saving technologies that can handle the immense data load without drastically increasing the carbon footprint. Then there's the challenge of data security and privacy. With 6G, we are looking at a level of connectivity that goes far beyond anything we've seen. An almost ubiquitous, always-on network that connects not only our devices, but also entire cities, medical systems, and even personal wearable tech. This means that the amount of data being transferred will increase exponentially, including highly sensitive information. How do we keep all this data secure? Quantum encryption is one promising solution, but it is still in its early stages. Meanwhile, governments, companies, and technology developers must grapple with creating robust security protocols to protect users' privacy while allowing for the kind of seamless data flow 6G promises. Standardization is another major hurdle. Unlike 5G, where international collaboration and standard setting took years, 6G will require an even higher level of coordination among countries, telecom companies, and tech developers. Establishing global standards is essential to ensure that devices and networks can communicate with each other seamlessly, but different regions have different priorities and capabilities, which can slow down progress. There is also the question of spectrum allocation, how to fairly distribute the bandwidth needed for 6G among nations and service providers, especially given the competitive nature of this technological race. Another consideration is the health and safety concerns associated with high-frequency radiation. While there is no conclusive evidence suggesting harm from these frequencies, public perception and concern must be managed carefully. Educating the public and conducting thorough research on the safety of terahertz radiation will be key to gaining widespread acceptance for this technology. Lastly, global cooperation is both a challenge and a necessity. Countries around the world are in a race to be the first to develop and deploy 6G, but without collaboration, the risk is that we end up with fragmented networks and conflicting technologies. To truly unlock the potential of 6G, there will need to be unprecedented levels of international partnership, ensuring that no one is left behind and that the technology benefits everyone, regardless of where they live. These challenges may seem daunting, but they are part of the journey to achieving a fully connected, 6G-enabled world. As researchers, engineers, governments, and private companies work together to solve these problems, we get closer to realizing the promise of 6G, a world where connectivity is instantaneous, intelligent, and truly transformative. In the next chapter, we'll explore the global race for 6G supremacy, which countries are leading the charge, and what's at stake in this competition for the future of technology. As we look toward the future of 6G, it's not just about advancing technology. There's also a high-stakes race underway, involving some of the world's most powerful nations. The development of 6G has become a new arena for global competition, where countries are vying for supremacy in a technology that will define the next era of innovation and connectivity. Let's start with China. China has made its ambitions clear. It wants to lead the world in 6G technology. The country was one of the first to roll out 5G on a large scale, and it intends to do the same with 6G. Chinese companies, backed by significant government funding, are conducting extensive research into terahertz communication, AI-driven networks, and the infrastructure required for 6G deployment. China views this not just as a way to advance technologically, but as a strategic move to influence global standards and set the rules for next-generation communication. For China, leading in 6G means greater technological independence and enhanced geopolitical influence. Meanwhile, in the United States, the competition is also heating up. The US government, along with major tech companies like Qualcomm, AT&T, and Apple, is investing heavily in 6G research. The US approach focuses on innovation and standardization, with an emphasis on ensuring that American companies are at the forefront of developing core technologies. The US also sees 6G as a matter of national security. By leading in 6G, the US aims to secure its position as a dominant force in telecommunications, preventing rivals from setting technological standards that could pose risks to data privacy and infrastructure security. The economic impact of leading in 6G could also be enormous, with the potential to generate billions in revenue and millions of jobs. South Korea is another key player in the race. South Korea has always been at the forefront of mobile technology, with companies like Samsung and LG being pioneers in 5G. Now they are heavily invested in 6G, aiming to launch their first 6G networks by the late 2020s. South Korea's focus is not just on being first, but on delivering ultra-reliable, high-speed networks that will transform everything from smart homes to autonomous driving. South Korea is also positioning itself as a leader in standard setting, which will be crucial for determining how 6G is implemented across different countries and industries. And then there's Japan, which is approaching 6G development with a vision of creating an ultra-smart society. Japan aims to integrate AI, robotics, and high-speed connectivity to address societal challenges, such as an aging population and the need for sustainable development. Japanese companies like NTT Docomo and Sony are leading research into terahertz communications and exploring how 6G can bring innovations like immersive remote working and smart healthcare to life. Japan sees 6G as an opportunity to push the boundaries of what technology can do to enhance quality of life and societal well-being. But what exactly is at stake in this race? Leading in 6G is about more than just having the fastest internet. It's about having the power to set the global standards for how the technology is used, which will define who benefits most from it. The country that leads in 6G will be able to influence how data flows across borders, how AI is integrated into networks, and even how industries like manufacturing, transportation, and healthcare adapt to a hyper-connected world. It also means gaining a significant economic advantage. Countries that pioneer 6G will have a head start in creating the services, applications, and devices that will run on this new network, potentially dominating the next wave of the digital economy. Moreover, 6G leadership has profound geopolitical implications. In a world where connectivity is power, being at the forefront of 6G gives a country influence over global communications infrastructure, making it an essential part of national strategy. It's not just about technology, it's about ensuring data security, controlling critical infrastructure, and shaping the future of innovation on the global stage. The global race for 6G supremacy is as much about collaboration as it is about competition. Countries need to work together to establish common standards, manage spectrum allocation, and ensure that this technology is rolled out equitably. Yet, the desire to be first is driving enormous innovation, pushing boundaries, and ensuring that the future of 6G will be nothing short of transformative. In the next chapter, we'll discuss the timeline for 6G, when we can expect to see this technology roll out, and the steps we need to take before we can experience this next generation of connectivity. The race is on, and the future is coming faster than ever. As we dive deeper into the future of 6G, one pressing question comes to mind. When will 6G become a reality? The journey from concept to everyday use involves multiple stages, and while the promise of 6G is thrilling, it's still a few years away from being part of our daily lives. Currently, we're in the research and development phase. Governments, technology companies, and universities across the globe are conducting early research to explore the potential of terahertz frequencies, AI integration, and new infrastructure needs. This phase involves testing concepts, running experiments, and working through the theoretical challenges to prove that 6G technology can meet its lofty goals. In fact, some countries, like China, Japan, and South Korea, have already launched initial research projects and prototype trials to explore the feasibility of 6G. This phase is expected to continue through the mid-2020s. The next phase will be standardization. If you think back to 5G, the move from concept to reality required a great deal of international collaboration to define what standards the technology would use. The 6G Alliance, along with other global bodies, will need to agree on the technical standards for 6G, how it will operate, how spectrum will be allocated, and how devices can communicate seamlessly across different regions. This standardization phase is likely to occur between 2025 and 2028. During this time, major players like the United States, China, Japan, South Korea, and the European Union will have to cooperate to ensure that we have a unified framework that works globally. Once standards are in place, we will move to the trial and testing phase, which will involve testing 6G networks in controlled environments to see how they handle real-world conditions. This is where we'll see 6G prototypes come to life, with limited trials likely beginning in urban areas or tech hubs. The aim is to understand how terahertz waves function in real conditions, how to overcome challenges like signal interference, and how the dense infrastructure of small cells and antennas can be implemented efficiently. Early trials are expected to begin around 2028 or 2029, and this phase is crucial for identifying issues that could impact full-scale deployment. If everything goes according to plan, we could see the first commercial rollouts of 6G by the early 2030s. This means that in the next 8 to 10 years, we'll start seeing 6G-enabled devices hitting the market, and specific regions will begin offering 6G services. However, widespread adoption will likely take several more years, as network operators build out the necessary infrastructure and refine the technology to make it accessible on a broader scale. It's also during this time that we'll start to see the real-world applications of 6G, holographic communication, immersive AR and VR, smart cities, and other revolutionary use cases come into play. But there are steps that need to be taken before 6G becomes a consumer reality. Building the infrastructure, small cell towers, edge computing nodes, and terahertz-compatible devices will require enormous investment and innovation. Governments and private companies will need to work closely to lay down the groundwork, ensuring that 6G doesn't just reach major urban centers, but also extends to rural and remote areas, providing equitable access to high-speed, next-generation connectivity. The timeline for 6G is ambitious, but if the past is any indication, the world of wireless technology moves quickly. We went from 4G to 5G in just under a decade, and the competitive pressure among nations and companies ensures that the push towards 6G will be relentless. By the early 2030s, we'll likely be entering a world where 6G is starting to shape our everyday experiences, providing unprecedented speed, reliability, and connectivity that will redefine what we consider possible. In the next chapter, we'll dive into how 6G will change our lives, not just in terms of faster internet, but in how we interact with technology, our cities, our workplaces, and each other. The future is closer than we think, and 6G will be the gateway to a world that once seemed purely science fiction. Imagine a future where technology doesn't just respond to us, it understands and anticipates our needs. That's the promise of 6G, a future where connectivity is so deeply embedded in our lives that it feels like an invisible extension of our own capabilities. In this chapter, we'll explore how 6G will reshape industries, transform our experiences, and bring about profound societal changes. One of the most significant impacts of 6G will be on healthcare. Picture a world where healthcare is not limited by geographical boundaries. 6G will enable real-time, remote surgeries, with surgeons operating on patients halfway around the world with the same precision as if they were physically present. It will also revolutionize patient monitoring, with tiny wearable sensors constantly collecting health data and providing instant feedback to both patients and healthcare providers. Imagine being alerted to a health issue before you even feel symptoms, with AI analyzing your data and sending proactive health recommendations. 6G will transform healthcare into a more preventive and personalized system, potentially saving countless lives. Transportation is another sector that will see a radical transformation. With 6G, autonomous vehicles will truly come into their own. Today's self-driving cars are limited by latency and connectivity challenges, but 6G's ultra-low latency and massive data bandwidth will allow vehicles to communicate instantly, not just with each other, but with traffic systems, road sensors, and infrastructure. Imagine entire cities where traffic lights, road signs, and vehicles are all interconnected, creating seamless traffic flow and reducing accidents to almost zero. Drone taxis could become a reality, efficiently transporting people across cities, all coordinated through the instant connectivity that 6G provides. Now, let's talk about entertainment. 6G is set to make virtual and augmented reality experiences so immersive that the lines between the digital and physical worlds will blur. Imagine concerts where you can have a front-row experience from your living room, complete with holographic visuals that make you feel like you're there in person. Picture video games where you are fully immersed, able to see, feel, and interact with a virtual environment as if it were reality. Augmented reality will change how we shop, allowing us to visualize products in our homes before buying them, or even try on clothes virtually with a level of accuracy that makes online shopping more immersive than ever before. In the manufacturing sector, 6G will drive the next wave of Industry 4.0, the era of smart factories. AI-integrated robots will communicate instantly, coordinating their movements with unparalleled precision to streamline production lines and reduce downtime. Machines equipped with sensors will create digital twins, real-time virtual models that allow engineers to test changes or predict failures before they happen, ensuring that production processes are more efficient, safe, and cost-effective. This kind of precision and connectivity will also enable on-demand production, allowing products to be made quickly and efficiently, tailored to specific consumer needs. But 6G is not just about enhancing industries, it's also about connecting people. One of the hopes for 6G is that it could help bridge the digital divide, especially in underserved and rural areas. By providing high-speed, reliable internet anywhere on Earth, 6G could make remote learning, telehealth, and digital job opportunities available to millions of people who currently have limited or no access to the internet. This has the potential to reduce inequality, giving people everywhere access to the same resources, education, and opportunities, regardless of their physical location. However, there's also a risk that 6G could create new inequalities if its rollout is uneven or prohibitively expensive for certain regions or demographics. If only wealthy countries or urban areas gain access, the digital divide could become more pronounced. Ensuring that 6G technology is developed and distributed equitably will be key to its success in improving the lives of people across the globe, rather than deepening existing disparities. 6G will also impact our social lives. Imagine holographic communications that allow you to see and interact with loved ones as if they're right next to you, even if they're thousands of miles away. Virtual meetings will no longer be constrained by two-dimensional screens. Instead, you'll be able to see holographic avatars of your colleagues sitting around a table, making remote work more engaging and effective. 6G will make our world feel smaller, more connected, and more immediate, enhancing human relationships in a digital age. Ultimately, 6G is about enhancing human capabilities and making our interactions with technology more natural, seamless, and intelligent. It will enable us to live smarter, healthier, and more connected lives, transforming industries and creating opportunities we haven't yet imagined. But the real challenge will be ensuring that this incredible power is used to benefit all of humanity, not just a select few. In the next chapter, we'll take a look at how 6G compares to 5G, the key differences that set it apart, and why this leap is about more than just speed. It's about a fundamental shift in what's possible in our connected world. As we stand on the brink of the 6G era, it's natural to wonder, what sets 6G apart from 5G? At first glance, it might seem like 6G is simply a faster version of 5G, but the reality is much deeper. 6G represents not just an upgrade in speed, but a complete transformation in how connectivity works, impacting everything from latency to intelligence. Let's start with speed. 5G already offers impressive data rates, up to 10 gigabits per second in ideal conditions. But 6G aims to push those speeds to 100 times faster than 5G, potentially reaching 1 terabit per second. This kind of speed isn't just for downloading movies in seconds. It's about enabling entirely new applications that require huge amounts of data transfer instantly. Think of real-time holographic communications or high-fidelity virtual reality experiences without any glitches. Then there's latency. 5G already made a huge leap in reducing latency, which is the time it takes for data to travel from one point to another. Latency in 5G can be as low as 1 millisecond, allowing for applications like remote surgery and autonomous vehicles. But 6G is aiming for sub-millisecond latency, reducing delays to virtually zero. This opens up opportunities for applications that require instantaneous response, such as controlling robotic systems in hazardous environments or enabling real-time augmented reality interactions, where even the slightest delay could break immersion. Bandwidth is another crucial area where 6G will excel. With 5G, we have seen a significant increase in the capacity to support multiple devices simultaneously, a necessity for the ever-growing number of IoT, Internet of Things, devices. But 6G will take bandwidth to the next level, supporting an even greater density of connections, up to 10 million devices per square kilometer. This will be critical for smart cities, where everything from streetlights to household appliances is connected and communicating in real time. 6G will provide the infrastructure for these billions of devices to coexist without congestion or loss of quality. A major difference between 5G and 6G lies in the integration of artificial intelligence, AI. While 5G introduced the concept of network slicing, dedicating specific parts of the network to different use cases, 6G will incorporate AI directly into its core. This means the network itself will be intelligent, capable of making real-time decisions, predicting user needs, and adapting on the fly to changing conditions. For example, AI-powered 6G could automatically allocate bandwidth based on current demands, improving efficiency and ensuring optimal performance for all users. Another critical difference is the use of terahertz frequencies in 6G. 5G operates in the millimeter wave spectrum, which is ideal for high data rates, but has limited range. 6G will push into the terahertz spectrum, offering even higher data capacities. However, as mentioned before, these terahertz waves have a shorter range and are more susceptible to interference from obstacles, which will require new types of infrastructure, such as dense networks of small cell towers and reconfigurable intelligent surfaces to enhance signal propagation. One of the most exciting aspects of 6G compared to 5G is the potential for immersive technologies. With 5G, we've seen the rise of virtual reality and augmented reality applications, but they still face challenges like lag and limited resolution. 6G will bring these experiences to a whole new level, enabling holographic communication, where you can interact with 3D projections of people in real time, and creating virtual experiences that are indistinguishable from real life. Imagine having a business meeting with colleagues from different continents, all appearing around the same virtual table, without any lag or glitch. This is the kind of leap that 6G promises. 5G was about enabling smart devices and bringing the Internet of Things to life. 6G will be about creating an Internet of Everything, a network that connects not only devices, but also senses, thoughts, and intelligence. It will be the backbone of systems that not only connect but understand, making our environments adaptive and responsive in ways that 5G could only begin to hint at. Ultimately, while 5G laid the foundation for a more connected and intelligent world, 6G is about redefining connectivity itself. It's not just an improvement in speed and capacity, it's a complete transformation in how technology integrates with our daily lives, making the world more responsive, interactive, and intelligent. In the next chapter, we'll explore some of the ethical challenges and implications of deploying such a pervasive and powerful technology. How do we ensure privacy, security, and equitable access in a 6G connected world? Stay with us as we dive into these crucial questions. As thrilling as the promise of 6G is, we can't overlook the challenges and ethical dilemmas that come with a technology of this magnitude. 6G isn't just about faster internet or better connectivity. It's about creating a world where almost everything is connected, constantly sensing and transmitting data. While this opens up amazing opportunities, it also raises significant ethical questions and challenges that we need to address to ensure that 6G is a force for good, rather than a cause for concern. One of the biggest ethical considerations revolves around privacy. With 6G, the level of data collection will increase exponentially. Every device, sensor, and wearable will be generating massive amounts of data, not just about how we use technology, but also about our daily lives, our movements, our behaviors, even our biometric information. This raises a critical question. How do we protect individual privacy in a world where every aspect of our lives could potentially be monitored? Without strict regulations and robust encryption, the risk of personal data being misused or falling into the wrong hands becomes a real concern. It's essential that we establish strong data privacy standards and give individuals greater control over what data they share and with whom. Another challenge is data security. The sheer amount of data flowing through a 6G network will make it an attractive target for hackers and cybercriminals. The stakes are even higher when we consider applications like remote surgeries or autonomous vehicles, where a security breach could result in serious harm or even loss of life. Quantum encryption offers some hope, promising levels of security that are virtually impossible to break. However, this technology is still in development, and the threat landscape will undoubtedly evolve alongside 6G. Ensuring that our networks are secure by design will be one of the most important tasks for developers and policymakers as we move towards a 6G connected world. Then, there's the question of potential misuse. 6G will enable a level of surveillance and data collection that, if abused, could infringe on civil liberties. Governments and corporations could theoretically use 6G infrastructure to track individuals, gather information without consent, or even manipulate behavior through targeted content in augmented or virtual environments. This type of surveillance could lead to a loss of freedom and create societies where people are constantly watched and analyzed. To prevent misuse, there will need to be clear regulations, transparency in how data is collected and used, and strict limitations on who has access to such powerful capabilities. AI integration in 6G is another ethical concern. The AI-driven nature of 6G networks means that these networks will be making real-time decisions, about what data gets prioritized, how bandwidth is allocated, and even predicting our needs before we know them. But AI is not infallible. It learns from the data it is given, which means biases in the data could lead to biased decisions. For instance, if AI systems are given skewed data, they could potentially make discriminatory decisions about who gets priority in network use or what content is recommended. AI transparency and fairness will need to be prioritized to ensure that 6G benefits all users equitably. Another challenge is equitable access. 5G has already highlighted the digital divide, the gap between those who have access to high-speed connectivity and those who do not. With 6G, the risk is that this divide could widen even further. If 6G infrastructure is only rolled out in wealthy urban areas, it could leave rural communities and developing nations even further behind. This would limit their access to new opportunities in healthcare, education, and business, perpetuating existing inequalities. Ensuring global and equitable access to 6G is crucial so that this next leap in technology benefits all of humanity, not just the privileged few. We also have to consider the health implications of 6G. While there is no conclusive evidence that the frequencies used by 5G are harmful, 6G will operate at even higher terahertz frequencies, and it's natural for people to be concerned about the potential effects of long-term exposure to these waves. Thorough scientific studies will need to be conducted, and transparency around the findings will be key to gaining public trust and ensuring that 6G is deployed safely. Lastly, the environmental impact of 6G is an ethical issue that cannot be ignored. The infrastructure required for 6G, from the dense network of small cells to the increased energy consumption, could contribute to a significant carbon footprint. As we build out 6G, we need to ensure that the technology is as sustainable as possible, using renewable energy sources, energy-efficient equipment, and innovations that minimize its environmental impact. The journey to 6G is not just about achieving incredible technological breakthroughs. It's also about ensuring that this technology is used responsibly. The decisions we make now about privacy, security, equity, and ethics will shape the future of 6G and determine whether it truly improves our lives or creates new challenges that we struggle to manage. In the next and final chapter, we'll reflect on the incredible potential of 6G and what it means for our future, a world where connectivity is limitless and the possibilities are endless. As we conclude this journey into the world of 6G, one thing is clear: the future is coming faster than we might think. 6G represents a monumental shift, not just in connectivity, but in how we interact with technology and with each other. To fully harness the potential of 6G, we need to prepare now, ensuring that businesses, governments, and individuals are ready to embrace this transformation. For businesses, preparing for 6G means thinking beyond traditional models and being open to new possibilities. 6G will bring opportunities that require rethinking products and services from the ground up. Whether it's creating new types of immersive customer experiences, integrating real-time data analytics to improve decision-making, or adopting digital twins to simulate and optimize operations, companies will need to invest in research and development, adapt to AI-driven networks, and be willing to innovate in ways that leverage the hyper-connectivity that 6G offers. Early adoption could mean a significant competitive advantage, allowing businesses to pioneer the next wave of technological applications. Governments, too, have a crucial role to play. To prepare for the 6G revolution, they need to focus on building infrastructure, ensuring that the necessary small cell towers and edge computing nodes are deployed efficiently and equitably. Governments should also work on creating regulatory frameworks that protect individual privacy, establish security standards, and promote fair access to this technology for all citizens. 6G offers an opportunity to reduce the digital divide, but only if governments are proactive in ensuring that everyone, including underserved rural areas and marginalized communities, has access to this advanced connectivity. Collaboration between countries will also be essential to establish global standards for 6G, allowing seamless interaction across borders and preventing fragmentation. For individuals, preparing for 6G is about being open to change and ready to adapt to new ways of living and working. The arrival of 6G will bring about changes in the job market, with increased demand for skills in AI, data analytics, network engineering, and quantum technologies. Staying ahead means embracing lifelong learning, reskilling to stay relevant in an increasingly connected world, and being ready to leverage new opportunities that arise. 6G will also change how we interact with technology, making digital experiences more immersive and integrated into our daily routines. Being aware of how to use this technology responsibly and understanding its ethical implications, especially when it comes to privacy and security, will be critical. Education and innovation are at the heart of preparing for 6G. Schools and universities need to focus on nurturing the skills that will be in demand: AI literacy, cybersecurity, quantum computing, and digital ethics. Encouraging STEM education, as well as fostering creativity and problem-solving skills, will ensure that the next generation is ready to make the most of what 6G has to offer. The leap from 5G to 6G isn't just about technology, it's about how we, as a society, use that technology to improve our quality of life, create new opportunities, and address challenges. Preparing for 6G also means addressing the ethical considerations we discussed in the previous chapter, ensuring that we develop and deploy this technology in a way that respects privacy, promotes security, and benefits everyone, not just a privileged few. By putting the right safeguards in place, we can prevent misuse, minimize risks, and create a future where technology empowers us rather than controls us. The future with 6G is one of limitless possibilities, where connectivity becomes so seamless and intelligent that it almost disappears into the background, enabling us to interact naturally with our surroundings and with each other. From real-time holographic communication to autonomous transportation, smart cities, and beyond, 6G will transform the way we live, work, and connect. But it's up to us to ensure we are ready for this change, embracing innovation, investing in infrastructure, and preparing ourselves and our communities for what lies ahead. As we stand on the brink of this next technological frontier, it's time to think big, stay curious, and get ready for the 6G revolution. The future isn't just coming, it's already here, and it's up to us to make the most of it. As we wrap up our deep dive into the world of 6G, it's amazing to reflect on just how far we've come in such a short time. From the early days of 1G, where mobile phones were bulky and only capable of simple calls, to today's 5G, where we can stream high-definition video, have real-time video calls, and even see the beginnings of autonomous vehicles. It's clear that the evolution of connectivity has fundamentally transformed our world. But what lies ahead with 6G is something even more extraordinary. We're not just talking about faster internet or better streaming quality. We're talking about a hyper-connected world where technology becomes a seamless extension of ourselves. 6G will empower holographic communication, smart cities, instant remote surgeries, and immersive digital experiences that redefine how we work, learn, and play. It will connect everything, everywhere, in ways we can barely imagine today, bringing us closer to a truly intelligent and integrated society. Yet, with all this potential, comes the responsibility to ensure that these technologies benefit everyone, address ethical concerns, and improve the quality of life globally. We have the chance to create a future where technology enhances human potential and helps solve some of our most pressing challenges, from access to healthcare to environmental sustainability. The journey towards 6G is just beginning, and there will be obstacles to overcome. But with innovation, collaboration, and a clear focus on what truly matters, we can shape a world that's not only more connected, but also more inclusive and intelligent. 6G isn't just about connectivity, it's about creating new possibilities, and we're all a part of making that future happen. Thank you for joining me on this journey into the future of connectivity. Stay curious, stay inspired, and get ready. Because the 6G revolution is closer than you think, and the road ahead is full of exciting opportunities that will change everything.